All right, live coding, doing an easy lead code problem, 35, search, insert position. Given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm with O of log n complexity. Okay, distinct integers. Are these distinct integers sorted? Yes. Return the index if the target is found. Good. And if not, basically it's saying, hey, do a binary search and tell me where you should add it. Fair enough. Let's start. Search insert, it gives nums, it gives target. You do search nums target and you start with 0 and nums dot length -1 as your full thing, and then you keep on doing binary search or something, right? So you go int search insert nums and r. So you got your mid, and now you do if it matches target, then you return, well, okay, let's do simply. If target is on the left side, then you look in the left side. Okay, when do you break, right? When do you break? Uh, okay, what would this mean? Well, if it was just a regular binary search, you probably would return -1, but now the twist is, if it's found, then there's no problem at all. But if it's not found, then you have to tell where it would be. And to check that, okay, let's see some examples. So here 1, 3, 5, and 6. We're looking at 5, so not a problem at all. Here we're looking at 2. Okay, so let's look at this example and see 2. So we got 1, 3, 5, and 6. Okay, your L is 0, R is 3, 3 by 2 is 1. You would compare with this and you would check, hey, there is no 2. And then you would compare with this, right? So what you could do is, in this case, you do one thing. If your it's quite interesting. What if L is equal to R? Um, okay, well, I'll figure that out. But okay, if so, basically what we're saying is it is on the left side of this, but it's in the left side, but it has on the right side of 1 as well. So if uh, mid -1 is greater than L or greater than 0, what would you call here? assume minus 1 greater than L, equal to greater than equal to L. And so what you're saying is target is lesser than this, but greater than this. Then that would mean this should be exactly where it is, right? And here if plus 1 is equal to R, and so what you're saying is the target is greater than mid and is less than 1, in which in this case also return mid. Now I think this works on most part. The part that is not covered is, let's say there is a single element, right? And 1 1, and yeah, you would cover a single element. It will not match, and then when you go to the left and you find that there is nothing in the left, then what do you do? So, which is if mid minus 1 is actually less than L. Is it possible? Yeah, it is, right? So if mid minus 1 is less than L, uh, you return L. And or basically it will be at mid minus 1. It will be at L, right? And you shift. Yeah. And here if mid plus 1 is greater than R, that means you return not R but mid plus 1, because it will be after. Wait, hold on. So you want it to be in the left, you want it to be in the right. Yeah, so in the left is right, is mid plus 1. Okay, I think I covered all bases now. And of course you can optimize, but okay, from a simple understanding, this is what I can get to. Okay, it accepts this. Example test cases. Accepts that as well. Okay, we'll submit, but let's just walk through the code again. So basically what you're doing is you're doing a binary search, but okay, if it's not found, then you want to also find where it would land. And for that, we are also checking its mid minus 1 and mid plus 1. Uh, if it's matching, there is no problem at all. If it's not matching, then okay, then we are checking it. It has to be on the left side of mid, but on just the next element. If it is greater than that, all right, then 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 this is where it will come. That means it's not present, and if it has to be present here. And similarly for the last case, and this for the case where just a single element is left, or if it's just a single element. I mean, this probably can be eliminated by. I mean, this single condition uh, can be handled separately as well. But okay, you can get multiple of. what if there are two, right? So yeah, I think handling there is better. I think we just submit. I think it's good. Okay, it says it's wrong. Interesting. 1 3 output is 0, expected is 1. 0 1. Okay, let's calculate. Um, so we go 1 and 3, 0 and 1. 0 plus 1 by 2 0. So we check 1 and we check that. Hmm, okay, yeah, this condition should never happen ideally, but we'll still keep it. Okay, so now you get this, you get this. You'll go into this condition. Is 0 plus 1 greater than 1? No, right? So we go here. Mid plus 1 is 1 is less than or equal to 1, and target is 2 is less than 3. You return mid. Okay, yeah, so this is the condition here. When you're returning mid plus 1, you should just return mid plus 1. And similarly here also you return mid, right? So since this is happening, you sort of make get the sense that you do if mid minus 1 is less than L or this. Return mid, and now you can get rid of that guy. And similarly, yeah, I think this is not needed. You should never go into this space now. So yeah, let's submit it again. And yeah, 0 millisecond, 100% faster. Alrighty.